Hello. So this is my second stream. It's like the second stream is kind of like a week after my first stream. So during this 1 week, I didn't study due to my other works and all the thing. But yeah, let me just okay. Then, so let's go and learn learn Go. Okay. Okay. So where we were, exercise, switch. We will start from switch. So, what is switch? What is switching do? So, a switch statement is a shorter way to write a sequence if else statement. It runs the first case whose value is equal to the condition. Switch state, sorry, Go switch is like a C++, Java, JavaScript, PHP, okay, except that Go runs only the selected cases, not all the cases that follow. In effect, the break statement that is needed at the end of the each cases in those languages provided automatically in Go. Another important part is that Go switch cases need not constant and value involves needed not to be integers. Okay, so like why we need runtime? Runtime, okay. So something that goes what it does. Let me just try run it. What Go runs on Linux. Yes, is okay. So the first line it print is Go runs on, and it just goes grab the grab the OS. Yes, grab the OS which the Go program is running. So as of so in this example, the Go program is running on Linux machine, which I believe it's Linux server. So whenever we try to run this program in in Tour Go, so it runs on a server uh, which runs on a server that and the server's OS is a Linux. Okay. So keys Darwin. Okay. Switch OS is Linux, then type Linux default. Okay. So let me just run this program in my PC. Let's delete, paste, D. So let me just go save it, exit it, go run cmd main.go. So go runs on Windows. That's nice. So with the help of this, we got to know that with runtime, it's basically like so. Runtime is an library for Go, which I think it catches everything that sorry, the it catches the information of the machine in runtime. So let me go and let me go for that, what's the option? G, wait a minute. RAM. Why is my LSP not running? Oh, okay, the runtime is undo, undo, yes. Okay, GOR, what it does. So it, yes. So for experimenting, we will go and print. So fmtp dot print. So what should we print? It should be print f. Print f. And this runtime runtime.org. So why not we just go and run it? Run. Okay. So what that statement is to do? I don't know. Not AMD. Ah, yes, my PC is AMD 64 bits. My PC is, yes. So it's go arch. So it goes grabs the it's grab the architecture of PC. So architecture of the goes we grab an architecture of a PC. So get some more what compiler error frames CPU profile. Okay. Yes, yes, it means that main means that okay, goes and run it. So the main stat is not an type. Okay, and then type. So what this is saying is that what it's saying is that main runtime is type is not an expression. So what it returns, we will go and open to look. We will go and learn what's runtime is not an import. Wait. During type is runtime. Okay, runtime is not a valid input. We will just runtime. Yes, it is a valid. So we will search for like names. Name, yes, name stack. Function read name stack. Okay, it's not. We will just go and text name stack. Okay, what's the error? Runtime name stack type is not an expression. So what it is? Like type name stack struct. Allocate select allow. It's unsigned integer. So it doesn't got any like minus signs or plus signs. So it's always a positive wherever there is in all the programming language when there is an unsigned integer or unsigned float or unsigned doubles. Yes, so what it means that it doesn't have any assigned, it doesn't have any sign. So like plus sign minus sign, yes, like negative my positive. So an unsigned integer is always an positive integer if you logically think about it, but yeah, it doesn't have any negative numbers. That's the basic, like, yes, that is the basic, what I should say, it's a basic basic fundamental of unsigned, uh, unsigned integer. So total is cumulative byte allocated for heap objects. Total allocated increases heap operators heap are allocated, but unlike alloc and heap alloc, it does not decrease when objects are freed. Does it have any beaver? Let's just check it. How to content. Wait a minute. Am I think wait a minute. Just wait a minute. I don't know if I'm currently streaming or not. Yes, yes I'm streaming. Actually, I'm streaming. I'm actually streaming. Yes. Objects are free. Objects are free. Yes. Yes. Sys is the total bytes of memory allocated from the OS. Sys is the sum of access field below. This is measure the virtual addresses. Man, I don't think that. I don't think I'm understanding any of this as of now. I will be understanding something. I will be understanding. I will be able to understand something of this documentation. Let me just go and name stat. Okay, name stat. Okay, okay, okay. Function name stat. Read names and populated with thing. So then we just go and what is name stat? Google. You should go Google it. NameStat is a simple tool that helps you analyze your application dynamic memory management. In particular, it helps you detect and find memory leak and multiple free. It may help you find other dynamic and memory error as well. Okay. Okay. So what is memstat? Memstat is list of all the accessible processes and executed memstat in Go. Go. Okay. So just go and hi. I don't understand what the value of memstat heap release represent. From what I read from the document, the amount of memory that has been created to the system. If you stop here, you should assume that this is value of the counter always growing and has not been reacquired for the heap. Things start to be weird here. So if I'm not mistaken, this value is no, sorry, this value is impacted by two things. Idle memory returned to the system. Okay, the idle memory reacquired for the heap. I don't understand why this has been split into two values. So Memstat heap released the total accumulated idle memory return to the system and Memstat heap reacquired. So total cumulative total cumulative idle memory reacquired for the heap. I think this would make easier to understand what would happen to the idle memory records. Was the reply? Okay, okay. Just so I understand, you're wondering what fraction of bytes that become the heap idle go into this state. Heap released before the transitioning back to the use state, or maybe it is something else. And I guessed follow on. Why do you need this data? What decision are you making based on the answer you get? Yes, you could do that if you want. You don't want to change the active counters. Okay. Yes, if we could do that in terms of the necessary, if you want to know what the data I speculated about above, we will. You did probably also need a total heap item. Tell what things that in doing this is something we can't tell about them quickly. So it does like I kind of understand that we shouldn't be touching this part. Yeah. As of now, we shouldn't be touching this part. So we just go and undo it. Go arch. So wait, I want to try something. I actually want to try something. So get. So we will go and stage it. Yes. So we will go staged. Then get C. It's GC. GC. Yes. Okay. So doesn't help me anywhere. So doesn't help me anywhere. We go quit it. Like all the changes I've done is staged. So it doesn't have anything like get signs. Let's get in. So we will go get GC. What should open me like staged. I want to commit it pending. Yes, how the hell should I okay G browse then okay and just go and commit commit so just go E for a E open the current file encounter C C commit map C A create commit C C C create C C the most similar is GC to know to C the most similar C GC no how to commit it actually how to commit go GC commit okay Please enter the commit message for the changes when starting with hash will be entered out. Okay, is the basic get messages. So was notified is mail.go. Try about it's switch cases also also try what runtime. Okay, my end is broken. My end is broken, so I have also tried runtime library or library slash package. So okay, okay, okay. So we will move towards switch cases. Switch OS. Okay, switch is maybe so let me just new information and information available and so switch case. So to use a switch case, we have to what? Mm, have to declare on what variable you should use switch cases on. So in this example, we are running on this OS variable. It ends here. Then we will continue like for cases. We will go write the variable. Then we will wrap the all the cases in this curly braces. So we'll wrap all the cases in this curly braces. Then we will write the cases that we have to I don't know well like we have to derive no, no, you can write like in these braces we can write the cases have to we have to run when this in this case matches. I think so that this is the best. Mhm. Okay, so when the case is Darwin, we just print the OS is Mac. Is Mac X? I think that is OS X. I don't know what OS X is, but I believe that it's Mac. Then if the case is Linux, so that is just print Linux. That OS Go runs on Linux, and then default is you just go print S. S. So we will go what is percent %s in Go. We will go Google it. So percent %s prints the value as plain string. Percent %q prints the value as double quoted string. Prints the value as plain string. So it prints the value as plain string. With width 8 left. Okay. Right justified, left justified. I don't know. Okay. We will try. We will try to run what 8s 8s s will go okay, so run right justified. So this this I think this then we will go around like we will go uh, okay left justified. So we will go and I don't know How do I run this? Do, 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 do. Test Q R2 go to go run this. As of now, that R string is a single, if you say a single string, it doesn't got any like two words or three words. So that's why it think that that's why it doesn't recognize it. Okay, 17 G. So okay. I think I do believe that we should be right. No, I don't think so. This should work. Okay. We will go. So we will move. Sorry, let's we just go and GT it. So switch cases also try to randomly because get log. This is great. We'll close it. Now move on to the next lesson. Switch evaluation order. Okay. My stream got two viewers. I didn't know. So second viewer, you can you can send messages. You can send chat to me. I do have like open my stream on the and my mobile, so I can watch. I can read your messages. Okay. Switch evaluation order. Switch case evaluated cases from top to bottom while switch cases evaluate for cases from top to bottom. So first this, second this, third this. Default default is always on the bottom, stopping when the case is succeeded. Okay. So I don't think so that yes. Hmm. I think that I didn't read, didn't notice this line. In effect, the break statement that is needed at the end of the is cases in those languages provided automatically in Go. So, I didn't know that. I think that my past experience from the other languages like C, C++, Java, and Python, I, I totally forgot Python, but I totally forgot Python syntax for switch. But if I remember, like whenever there is a switch case, like or whenever there is a case, we have to break. Yes, we have to add break at the end of every cases to shit. How do I do it? Control C, Control C. Press up to Control Z. Yes. So it automatically provide what break statement at the end of the every succeeded case. I think it's kind of easy. Like it what it makes syntax easier to read. Yes. Like, so we will just go and what I will just copy it. um, readability readability of So I think I do believe that without this, like if we include break statement, the readability of this program. Oh my God, my God. Okay. So if we add break statement, you can guess that the readability of this program just goes into trash. Like we know that if we just that if this case is true, then whatever it is run, yes, like whatever it is executed, yeah, then why do I have to include break? We know that it's just an end statement. So without without those, I will be like uh, print ln lost heaven. Yes, run it. When Saturday 25125. When Saturday. Hmm? Not Saturday. Okay, okay. It's too far. I think it's too far. It's not even. So we'll get to grab it, paste it, run it. So okay, too far lost heaven. That's it. So this is the end statement. So we shouldn't include break. It automatically given by the Go language. Yes. Reset. For example, switch I case. Switch is again stopping at the case when successor succeeded. Does not call F if I equals to 0. No, the time the go program always appears to start at 2009 value to less significant is left as an exercise of the reader. Should I run it now? We'll just go with next lesson. Switch with no conditions. Switch without condition is same as switch true. This construct can be clean can be can be the clean way to write long if then chains. So if you can notice whenever there is a switch there is an variable. Yes, there is an variable. So with no conditions, like what what it means that if this exists then run this. Yes, I do believe that this is this telling us this. So if the conditions, if there is no condition, this switch statement is true. So like whenever there is no condition for switch, it always runs. There is no true or false. I would try something on. I actually want to try something. Just go and go T paste this actually false, and then what we will print, what exited exited switch to go cmd main go switch. So if we write switch false, so it means that this switch we should. So what it means that we so what it means that whatever it is present in this switch case, that this switch operator, this the switch cases is not gonna be run. Yes, I do believe. Okay, we will go do it. Shit. It's not. We will not undo it. Yes, we will go run it. Yes, exit or switch. I believe that it should be running now. Wait. False. System to switch. Exit or switch. So false. I think it's that false doesn't run. So this false thing doesn't work. It doesn't actually work. Shit. It doesn't actually work. So it's not false. So if there is a false, so it doesn't mean that it should run. So it shouldn't run. Even if there is a false or true, it runs. It runs. We will have to check it that when this switch case is not run when there is no condition. I think so. So we'll just go and it. We'll go stage it. And yes, CC. It does it. Does it do. So we have to fast type the CC. Let's double click the CC. What am I doing? Which is no conditions. Conditions. Man, I think so that false. Correct. Previous station. It CC. Or should I go like paste? Switch previous switch is previous which is no conditions. How do we do that? Yes. GT 3 base conditions. Okay. The conditions. These conditions. Spelling. Oh, it nice. Defer. So, so we'll go now to the defer, which I think that defer concept is not implemented. It's not introduced in other languages. So I think it's defer is original for Go. Okay, defer concept. So we will learn it. So what's defer? Defer statement defer statement defers the execution of the function until the surrounding function returns. The defer call arguments are evaluated immediately by the function call is not executed until the surrounding function returns. Let's say we'll just go and run it. Hello world. Does it have any examples? Stacking defers. Defer statement defers the execution of the function until the surrounding function returns. So I think I kind of know. Like I'm understanding something. This defer statement. So what it means that until all the other functions execution are done, then and only then the function with defer statement will run. So whichever whichever function got deferred will run at the last, at the end of the execution, like at the end of the program execution. Yes, I think defer means this. I like it's saying the like whatever I'm saying, it's just an what an evaluation of the statement. Yes, I think so. We'll just go run. I don't think so that it should be run. Stacking defer. Defer function calls are pushed on the stack, which sorry, when function return it defers call are executed in last in first out order. Skip. Okay. This is stacking. So I think that like for whatever reasons, last in first out. So if we think about it, then it's like what this function is doing. For I equals to 0 and I till I is less than 10, increment I and then print I. So at last the print statement for I execute is when the I is equals to 9. So the first print statement will be the 9, then 8, then 7, 6, 5, 4, 7, 8, 9, 10. Okay, like till 0, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. To learn more about the first statement, read this block. Okay, so we will just pause this stream. Just go and pause the stream. Share pause screen. Okay, so the stream is resumed. Yes. Okay, so I kind of understand like what defer means. Defer follows the last in first out order. We will learn more about defer after this blog post. So we will read this blog post. So defer, panic and recover. This blog post is written in it's posted in August 4, 2010. Okay, so it's old, like it's a decade old. It's written by Andrew Geraint, who has the usual mechanism for control flow. If for switch go to, it also it also has the go statement to run the code in separate go routines. Here I would like to discuss some of the less common ones: defer, panic, and recover. So recover. The defer statement pushes a function onto the list. The list is saved, called in the execution, called to the execution, sorry, executed after the surrounding function returns. The defer is commonly used to simplify functions that perform various cleanup actions. For example, let's look at the function that opens the two files and copies the content of the one file to the other. So this is function copy files goes around and what is this file? It is source name and string is destination name, source name, its string. We will go return in 40 and 64 or yeah, I like this or error. So we'll just go SRC and we initialize it as OS open SRC name. So we just go grab so grab the file, open the file. If is nil. If is null, so is not null or not nil, we will go and error handle it. So it's just it's an error handling. It's an error handling. So so if the error so if there is an error while opening the OS, if there is an error while opening the opening the file, we will handle the error in this section. So in this error handling, then we will just go grab the destination destination. So I create and it also follows error handling. So, so just go create and create the file at destination, return here copy. So it does it copies the no, okay. So what it does it copies the all the things that are present in the second argument, which is src, and paste it in destination, which is in destination file which is first argument. Then we will close the destination destination file. Then we will also close the src file, source file. Then we will return nothing. Okay, this works, but here is the bug. If the call to the OS create fails, the function which will return without closing the source. This can be easily written by putting a call to src close before the second statement. But if the function were the problem might not be easily noticed and resolved. By introducing the first statement, we can ensure that the file are always closed. This works, but here is the problem. So in this error, in this function, the error is that, so if there is a bug, which is by mistakenly, if we forgot, yeah, if we forgot to close the file at the end of the function, which always has, which always is at the end of the function, we have to close whenever there is a file open, we have to close it. It's an uh, golden rule of an programming. Yes. So whenever there is a changes, we have to backtrack it. It's like that. So we open the we open the source file. We created the destination file and opened it. So we have to close it. We have to close the destination file, and we have to also close the source file. So in here, so with the defer function, so what we do is that whenever there is a source, so whenever source file is open, we just go and right, we just close it, but we add defer statement. So what it does is this statement, this src.close, is executed at the end when all the function contained in this function are returned. Like all the functions are returned. Then we open destination file, we also close it with defer. So it executed at the end, then we return it. So when this return statement is done, like when this return statement is executed, we just go and we run for first in, last out. Sorry, last in, first out. So the first thing that closes is the destination file. Then what it closes is source file. Okay. The defer statement allows us to think about the closing each file right after opening it, guaranteed that regardless of the number of the return statement in the function, the file will be closed. The behavior of the defer statement is straightforward and predictable. There are three simple ones. First, a defer function argument are evaluated when the defer statement is evaluated. The defer function arguments are evaluated when the defer statement is evaluated. In this example, the expression I is evaluated when the println call is deferred. The deferred call will print the zero after the function returns. So, in this function, so I think I do believe that the answer, the what will be printed is I equals to 1. No, 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 no. Cannot we just go and run this? Dot e just to paste it. And we call this where do we want? Then we can just want to try something. Why this EI TV we paste shift. Why I curly braces then it should be paste to delete it to and da this ed to run this to run cmd main is not used. It's unused. I forgot. But that code doesn't zero. So what it means that this print ln stores the I value which is in the past. Then I'll make them. So in this example, the expression I is evaluated when the print statement is clear default. The default call will print 0 after the function returns. Yes. So, so what it means that I think what it means that it this print statement this print statement will print the I at that instance. What I was what I was what was the I what was the value of the I when the print statement was called. So it doesn't go and verify this. I is it doesn't go and check the current value of the I. Yes, just go and print the value of I value of I when the print statement was called, when the print statement was evaluated. Means this. So we will get stage. Wait a minute. The defer function calls are executed in the last input. Okay. Last in first out of the surrounding function. We knew last in first. It follows the last in first out order. The defer function may read and assign to the return function and return function may return values. Defer functions may read and assign to the returning function named return value. In this, I kind of not understanding this line statement. So we'll just go and verify this. Like we will just go and learn more about the statement from the example. In this example, a deferred function increments the return value and value I after the surrounding function return. Thus, this returns 2. Yes, A also C L deferred. This is convention for modifying the error return value of the function. We will see an example of this shortly. Panic and recover. We don't think so. That should I cover it? It's actually it's not that big, so we will cover it. Yes, panic. Panic is a built-in function that stops the function that stops sorry, is a built-in function that stops the ordinary flow of the control and begin panicking. While the function while the function f calls the panic and execute f stop Any default function are executed. Any function in f are executed normally. When the function f calls panic. So when the function f, then I just call it the naming function trash. So you just go when it's like when function calls when the function lost heaven calls panic. So the function lost heaven stop executing. Any default function in lost heaven are executed normally, and then f returns to its caller. To caller, the f then behaves like a call to panic. The process continues up to the stack until all the function in the current go routine go routine have returned. At which point the program crashes. Panic can be initialized by invoking panic directly. There can also be They can also be caused by runtime errors such as out of bound array access. Recover is a built-in function that regains control of the panic routine. The recover is only used inside the defer function during normal execution. Call is call to recover will return and return nil and have no effect. If the during normal execution call to recover will return nil function and have no other effect. If the current go routine is panicking, a call to recover will capture the value given to panic and uh, resume normal execution. Here is the example. Okay. I totally didn't understand any of this. Like I kind of understand something, but what should I say? All the other things are like bouncing bouncing around my head. It's just all the information are bouncing. It goes to here is the example program you can demonstrate the mechanism of panic and defer. This panic, defer, and recover. I think so. So with this instruction, we call f. Okay, we call f. Then after calling, like after executing any function, we will print return normally from x. So what f function does? So it just go it, it have the first statement around the function. So it means that this this function is executed after this f function is executed. Like, after this last statement is executed. So what this is like if r equals to recovery and r equals if r is not equals to nil, recover in f. Recover in f. The entire g calling g0. Okay, then we will call g function which accept int as an argument. So if I is greater than 3, printf panic tp. Okay, okay. So I think this should be executed while I think so that this should be executed. Should This should be executed first. C is calling tree. What? Let's go and cls to run cmd main So what it means. So we will follow all in G. So it doesn't panic. Printing G I, defer in G last. Then just go and print C. So just go around. It's normal. Printing G0. Okay. Then there's panicking. So then it goes like then it prints all the defer values G3, G2, G1, G recovered from F4. Okay, normally so, I think that okay, we should read the documentation for recover. The recover built-in so the recover built-in function allows program to manage the behavior of any query. Executing a call to recover inside a defer function, but not to call the stack anything. Actually, I kind of don't understand this recover panic. No, listen, like I kind of understand panic, but I don't understand this recover function. I don't understand this. Actually, I don't understand it. So we just go around. It, it, what's the difference? Okay, it's a commit. It's a commit. Okay, so I think so that I don't really understand this recover. We will understand it in future. I'm not trying to load my brain. We will move to the next chapter. Now we will finish this lesson. We can go for more next lesson. Then we will go to the next lesson. Okay, man. It's massive. It's actually massive. You can see all those things. We are actually in the pointers. And we are in pointers. And methods. Okay, so more types struct, dice, slice, maps, pointers, struct, fields, pointer to struct retrieve, array, slice. It's basic. It's basic for Go, but I think so that it's it's hard when we start to learn a new language. Pointers. Go has pointers. A pointer holds the memory address of the value. The type star pointer to the t value. Its value is nil. Where p is the end of it is the star type pointer to t values value Zero value is nil. The AND operator generates a pointer to the operand. The As the star operator. The star operator dominates the pointer underlining values. The FMTP reads to the pointer. Set the pointer. Okay. So let's go and run it and result. I is 42. I will FMTP print ln p string print ln n is not present. So and is the address to the I. So likewise, this is the address of the I operator. No, sorry, I variable, and if we use star p, it goes like it's a two-step process. So first it goes to the pointer, then it so like first it goes to the pointer which is the pointer of I, which is the location of an I, then it reads the value of the I. Actually, it reads the value and displays the value. It prints the value of I. It's a two-step process. Escalator, carry, escalator, Google. Should be the okay. I should be itself. I I equals to 42. I equals to 42. So the the location of this location the location of this I variable is this this. So what p stores what p stores what this p variables what this p variable stores is this p variable this p variable store is the address of I. So if we if we display star p, if we display star p, it means that it goes like this. Okay, okay. But it means that this p, it, so first this thing goes to the address. Yes. So in the star thing, the star operator goes and what like and takes the value and it reads the value at that address. Like it reads the value of I. So like this operator, the star operator reads the value of I. So it shouldn't be framed like this. The star operator reads the value reads the value present in the address present in the address present in the address. That's it it just that's it. Okay, so what circuit does is that it's almost clear to me. It's in basic. It's in basic. So I think that like I have to go and like commit it. Wait a minute. I have some personal messages. Shit. My friend wants the his username. So, I'll go and send his username. Yes, that's it. Done. Structs. Struct is a collection of fields. Actually, struct is like a class of other function. Sorry, of other languages. Struct is like a class of a class in other languages. Struct. Struct fields. Struct fields. Struct fields are accessed using dots. Just like how, just like how we access objects of class. That's how we access struct fields by using dots. It's it's an good concept, like the naming convention. In other language we call it class, in Go we call it struct. That's it. Pointer to struct. Pointer to struct. The struct field can be accessed through wait a minute. Just wait a minute. Sorry, it is not available. Wait a minute. Just currently trying it. My stream is available in stream live. Okay, an unknown user follows you. Thanks. Actually, thanks. Oh my god. My stream is on for 1 hour 20 minutes. I didn't know. I may not able actually actually trying to guess it. That is not able to change the layout of things. Okay, I don't know, but I think so that I will have to follow the just this. And so I will be reading other things with pitch and also on YouTube. Yes. Pointer to start. Okay, pointer to struct. The struct field can be accessed through to struct pointer to access the x field. To access the x field with the struct. When we have this pointer p, we could write yes. That actually we could write this. However, that notation is cumbersome. So the language permits us instead of instead of just write p dot x without the explicit dereference. Yes. What is what p store is the address. So if we in convention, if p dot x, it just means that it's a photo address and whatever the value, sorry, whatever the address is stored of x we display it. It's it's there's it that is, but 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 with code we it's like star p dot x, like star p dot x. So it just goes to so it just go to the it just goes to the address, then it goes to the value, then it goes to the field x, like it goes to the field x. It's kind of it's kind of jumbling, but it is easy if you think about it. If you know what this means, like it's pointer the values in the struct v, like it's v vertex v, in struct v. I have to access x. There it goes. Yes, this is the v100 one exponential 1 raised to the 9. Is the 6 one if you know exponential things. Why not you just go and 12? So it will be 12 2. Yes, yes, this is 12 2. We can modify it all around the 16 to yes, it's easy. It's easy. Think about it. So then we must do literals. The struct literals denotes a newly allocated struct by listing the value to its field of its field. You can you can just a subset field by using the name syntax. You can just list a subset of the field by using name syntax. The order of the name field are irrelevant. The, the special prefix returns a pointer to the struct value. Hmm. So V1 is 1 2, V3 is X, okay, X1, V3 is empty, P is pointer to the pointer to the struct vertex 1 2. I think that I don't know what it should print. So it just print pointer to this thing. I don't think that we will be most likely be using struct literals, so we can just skip this array. The that we array should be used. Array is always used in any languages, any programming languages. Array. The type the type bracket n t is an array of n values of the type t. Okay, so in this in this n is the number of variables, sorry, number of values it can store, number of values it can store. So it's an syntax for declaring an array. So in this n is the number of values and t is the type of the array, that type of which type of array like we want to declare. So in this we are declaring the name of the variable is a, the value, sorry, the number of values should be 2, and the type of the array is string. So at first, like, at the first index it should store hello, at second index it should store world. So if we print a0 a3, it will be printing hello world. It will be printing hello world without space. And then there is other, like, other other ways of declaring, so other ways of declaring an array, like primes, this colon equals to operator, then goes and assign this in this specific main function with this sample. The length is 6, the type is int, the values inside the prime are 2, 3, 5, 11, 13. And let's go and display primes. If I go around 17, okay, actually it is, I didn't know that how it works. Actually, I want to know. I thought that hello and world will not have any space. It has a white space. It actually has a white space. I'll have to check out this afterwards. It means this. See, like it's just a generic way of using an array into. It's insane. They declare a variable a as an array of 10 integers. It's saying straightforward. An array length is part of the type, so array cannot be resized. This seems limiting, but don't worry. Go provide a conventional way of working with arrays. Like dynamic arrays. I think so. I think so. I don't know. Like if I didn't know that Go has dynamic array or not. Slices. Like, we will move to the next topic, which is slices. Slices. An array has fixed size. A slice, on the other hand, is dynamic size. Flexible view into the element of the array. In practice, slices are much more common than arrays. Yeah, in C++, we got vectors, and Go we got slices. Like, vector is just a dynamic array for C++, slices is just a dynamic array for Go. Actually, actually, it's not a dynamic array. Like, it's kind of dynamic array, but it's kind of not dynamic array. I think so. Okay. The high, lows, the type, the type. Okay. We don't have any length. We just have type. The slice with element of type D. A slice is formed by specifying the two indices, a low and high bound, separated by colon. Separated by colon. Okay. This low bound, high bound. This select a half open range, which include the first element, but but exclude the last one. So this following expression a1 colon 3, so it means that the value is 1 2 3, it's supposed to 1 2 3, not till 4. So the expression create a slices which includes the elements 1 through 3 of A. So it should be 1 2 3. Okay, so prime first to fourth. Hey, Ben, actually, it's not. I take back my words that it's a dynamic array of code. Like, actually, it's not a dynamic array. It's just a slicing of Python. If you if you have worked with in Python, so you kind of know like what is slicing. Actually, it's my dumb brain. Like it's my dumb brain that thought that this is an dynamic array. It's a vector. Actually, it's not a vector. It's just a slice function of Python. So we'll move to the next. Slice are like reference to the array. Slice does not store any data. It just describes a section of an underlying array. Changing the element of slices modify the corresponding element of this underlying array. Other slices that shares the same underlying array will see those changes. So we have we have name, we have array of name, which is of this can store up to value 4. Which is, the limit is 4. The type is string. The values are John, Paul, George, Bingo. It brings the all the name in array format, that is bracket quotes John, quotes Paul, quote George, so John, quotes Paul, quote George, quote Ringos, and then close, what's that called, close square brackets. So then we declared an array array with stores names of first to 2. So it stores 0 and 1th 0 and 1th index of the array. So A stores John and Paul. B stores 1 to 3. So at index 1 is Paul, at index 2 is George. It doesn't store 3 third. So it store Paul and George just like that. So if we print A and B should be bracket John Paul and bracket Paul George. Then there is B. Okay, equals to, so B 00. No, sorry. P at the index of 0 should be XSX. It, I think it doesn't affect it. We are modifying the B value of which is Paul. So I think that Paul name shouldn't be changed. Okay, it changed. It changes. So it's just like a reference. So whatever we modified in those reference will be modified at the end of the original. So whatever we modified in children class, we like send like we will go to the example. So it's not this, it's this. Okay, we'll go delete it. John, 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 Raj, so yes, this is my naming connection. So, so this is an array which contains this. The array is A. Then we got B, restores only this part, this, and then there is also other array restores restore this, which hold this. So if I go around and change, actually I should name this B. I should put this, put C, C. Okay. So if we so so if we modify the C, like we modify, we change the name of Ram with what? With Krishna. So like if we change the name of Ram with Krishna, what if so in the original this array also in this array the name of the Ram will also be changed to the Krishna. It's just a reference thing. The slashing is just an reference. Okay. Slash changing the element of the slashes modify the corresponding element of its underlining array. So whatever changes happens in this array will go to the array. Whatever changes will happen to this A or B array will also be corresponding to this to their original array, to their parent array. Other slices that shares the same underlying array will also see those changes. So if we take like B and A has something in common, which is Paul, which is Paul. Yeah, is Paul. So in this statement, we change this Paul to XXX. Then I will just go and to Ram, Ram. And whatever is there. At first, we'll change the first name of first name of B, which is okay. It will go change to this Ram. Then it will also go to their. Then it will go to their parent, which is names. Which is names. It will change the call to Ram. Then it will go to check. Does Paul also includes in others also underlining arrays like subarrays of B. So it will go and check that okay man, A also has Paul. So Paul should also be changed to run. If you run it, like yeah, Paul run. Yes, this should be go CMD name. Yes, this. Actually, why did I run this? G, GC classes are like refer- references to references to array. Shit. So on to the next lesson, slice literals. Slice literals. Slice literals is like an array literal without the length. This is array literals. To in this way, the same array to page the reference to it. It's just a literals, like how to use. When the lessons are massive, so 23 and we are currently in 10, so 27 and we are currently on 10 lessons. Lesson number 10. Chapter number 10, Slash defaults. When slashing you may omit the higher or lower bound to use the default instead. The default is the 0 for the lower bound and length of the slice for the higher bound. Think I think I should stop this stream for resting. I will be stopping the stream for now. I will be I'll be streaming at around 7 o'clock, 7:30. Yes, I will stream around 7 or 7:30 or if, or tomorrow. I think so. But I will try that. This stream should be complete. I think I will be streaming 2 days, like second time, like 10 or 7 or 7:30. I'll be streaming at 7 so I think so. So let me just end this stream.